That's it. So thanks to Trevor Knight for doing our foray into functional programming with Elixir, and thank you over to you.
All right, so I've been doing, I started out doing web development, so the typical web development tools and languages, so Ruby, JavaScript, PHP, all that kind of stuff. But recently, the last year, I've been doing some functional programming with Erlang and Elixir. So I kind of wanted to talk about my experience with Erlang and Elixir. I'll be focusing on Elixir in this talk, but Elixir and Erlang are very closely related. So I'm kind of assuming that most people have a pretty good understanding of object-oriented programming and things like methods and functions and variables and all that kind of stuff. So I'm going to kind of quickly go over the basics, and then when we get into the stuff that's kind of specific to functional programming, I'll take a little bit more time to go over those concepts. So I'm Trevor Brown. I do Ruby, JavaScript, and now Erlang and Elixir. I live here, and I work at Volt, and we have an office right over there. So these meetups are really convenient because I don't have to travel anywhere. But yeah. And so to get started with Elixir, this is just kind of a brief overview of it. Elixir is a programming language that's built on top of the Erlang VM. It compiles down to bytecode that can be run by the Beam virtual machine or the Erlang virtual machine. And so because it's closely related to Erlang and it compiles down to the same bytecode, it helps to have an understanding of what Erlang is. So both of these languages are very different from object-oriented languages. They're functional. They're intended to simplify concurrent programming. They were also built for real-time or near real-time systems, and there was a specific set of problems that they were built to solve. But a lot of these issues, like near real-time systems and concurrent programming, those are becoming much more relevant today as processors are splitting off into multiple cores and machines really aren't getting that much faster. So the main goal with Erlang is to simplify concurrent programming, and it has a unique let it crash error handling philosophy. So the idea is that with let it crash is that if something goes wrong, instead of catching an error or trying to recover, you kind of let the error happen, let that process or whatever was executing that code crash, and then get back to some state in the application where you know things were stable, and then try again. It kind of seems kind of primitive, but it turns out to actually work really well in the real world. It's not as it actually works out a whole lot better in real life than it seems. You actually don't lose a lot of stuff if you've structured your application right. So when something goes down, you can actually quickly recover, and there's very, very rarely is data actually lost in a well-designed application. It's compiled down to bytecode, runs on the Erlang VM. It was designed and built in the 80s by Joe Armstrong, and of course it's designed for real-time systems that have need to always be available and always have a lot of uptime with not a lot of downtime. So that was the basics of Erlang, just an overview of what that is. So what is Elixir? And Elixir is another language that's built very similar to Erlang. It compiles down to the same bytecode, so the virtual machine, the Erlang virtual machine, is executing the same type of instructions. So it is also a dynamic language, or dynamically typed language. It is functional just like Erlang, and it inherits a lot of the strengths and weaknesses of Erlang. So you can use Elixir to build the same type of fault-tolerant distributed applications that are concurrent. It's a relatively new language. It was started in 2001 by Jose Villim, and his name is actually pronounced Jose. It's not Jose. He's actually from Brazil, so he's actually Portuguese. So their pronunciation of words and all that is very different than Spanish. So the first version of Elixir was released in September, so it's very new. I've only been I've only been experimenting with it for the last year, and it's just recently become stable. So you may have heard about Erlang and Elixir, and there's a lot of talk. Elixir's been getting a lot of press on like Hacker News and stuff like that. You see it up there quite often, and there's a lot of people talking about it because it's a whole lot newer than Erlang. It has a nice new syntax. It doesn't have that syntax that's from the 80s that everybody hated with Erlang. So a lot of people are talking about it, but not everything you hear is entirely accurate. So put this up there as a myth. It has some truth to it, but this is really not true. So Erlang has a syntax, or Elixir has a syntax. It's very much like Ruby, but it is not at all Ruby. It is still Erlang underneath. It compiles down to the same bytecode. Still a functional language. Still has all the features that Erlang gives you, like pattern matching, recursion, and immutable data, and stuff like that. Another thing you might have heard is that Elixir is just like CoffeeScript for Erlang. So you get to write in this nice, better syntax, and then it's transformed into Erlang bytecode, which is then executed. And this is also kind of true. It is actually compiled down to the same bytecode, so it is kind of like CoffeeScript. But it's a whole lot more than just a better syntax. There's a whole suite of tools. They redid the documentation. Metaprogramming is actually possible in Elixir. Metaprogramming is nearly impossible in Erlang. Even though there's support for it, it's something that almost nobody ever tries to do because it's so difficult. And then also with Elixir, they provided some better data types, so they actually built some stuff on top of it. So it's a little bit more than just something like CoffeeScript. So why use Elixir? Well, Elixir is not for everything. It's intended to solve specific problems. But for anything that you would want to use or need to use Erlang for, you could use Elixir for, and it's usually is more productive than Erlang because you don't have to deal with the syntax quirks and all the stuff that comes with that. You get the better tools, so development is much quicker. Unit testing is far easier in Elixir than it is in Erlang. You get the better syntax, and you get metaprogramming, which is very nice. It's very well done in Elixir. It's actually pretty simple. If you spend a couple hours, you could probably wrap your head around it, even if you hadn't used Elixir before. So that is kind of what Elixir is. Now I'm going to go over some of the actual looking at some syntax and going over the data structures and stuff like that. Before I move on, does anybody have any questions so far? Okay.
Is it used for artificial intelligence at all?
What?
Is it used for AI?
I don't know, but I think some the concurrency and the way that's set up, I would think it might lend itself to AI in some cases.
You talked about being able to recover from a trashed attempt at something.
Right, yeah. So when that happens, you usually everything is running in an Erlang process or an Elixir process or whatever you want to call it. So when something goes wrong, normally you just let that process crash and you have another process take over and fix it up. So yeah, that might lend itself to that. I don't know, but that's a good point. I've never really looked into that, but I would imagine it would lend itself to that.
The VM, is there a reason why or an advantage between this VM and the JVM?
So I don't know a whole lot about the JVM, but the Erlang VM has some very distinct advantages to it. When I go over, I'm going to first go over the data types and the basics of the syntax, and then I'm going to go over things like pattern matching and recursion and first-class data structures, and then I'm going to get into concurrency later on. And I will go over the specifics of the VM and stuff. And it's quite powerful. I'll show you a demo at the end where I'll spawn 10,000 concurrently running processes, and I'll send messages around and stuff, and it will be very quick. So it's definitely a whole lot different than the JVM. I don't know enough about the JVM to actually point to specific examples But yeah, it's a very different virtual machine. So yeah, so I'll go over pattern matching, first class functions, and then I'll go over recursion, and then basic concurrency. But before I do that, I'm going to go through some of the basic data types. So all data in Elixir and Erlang is immutable. So whenever you add something to the end of a binary, or you change a string, or you add something to a list or a tuple or anything like that, you're actually underneath making a copy of it in some way. So the most basic data type is the atom, and atoms are just like symbols in Ruby. They look like that. So we have an atom called hello world, or an atom called A, and there's also booleans, which are actually atoms underneath. So in Erlang, this is actually represented as an atom as well. In Elixir, they add some stuff over top of it to make it actually look like a boolean. You can do all the stuff you would with booleans on that. There's also binaries and numbers. So very simple, integers and floats. This is a binary representation of the string ABC. So you see here, we're actually constructing a binary with 3 character codes that represent ABC. And then here, this is a little bit more readable, but we're actually constructing the same string, but we're actually literally typing inside quotes ABC, and that's converted to that underneath. Both of these are binaries, and they're both equivalent. Tuples are ordered collections of elements with a fixed size. They're usually used when you know you have a fixed number of things. So in this case, we have a tuple of 3 items, three atoms with the names of numbers. And here we have a tuple that contains 4 items, 4 integers, I should say. And you can't really easily add or take away items from a tuple. They're for storing set amounts of things. If you want to access an element within a tuple, you can use this function here and extract the value at that index. So in this case, we're using 0. We're extracting the first value from this tuple, and it's returning the integer 1.
And the point is, this isn't some kind of pointer to the original. As you said, this is a copy.
Yeah, so
it's a completely separate number.
yeah, so this is, yeah, if you were to, while you could actually, there are functions that would allow you to take this tuple and construct one with 4 elements, you would be making a copy. So you would be taking whatever, all those things in memory and duplicating them and then adding something onto them. There are some data types that I will get into, like lists, that are a little bit different. So there is no array type. A list is actually a linked list.
Okay.
So each item in the list is actually that value in memory with a link
to the next one.
With a link to the next item in memory. So because of that, it's very easy to add things onto the beginning of a list, because you're simply putting an element in memory and then you're adding a link to that to the rest of the list. So adding items to the beginning of the list is very easy. Most things in Elixir aren't like this. Normally you're actually making complete copies. Lists are different because you are still making a copy of it, but you're not having to duplicate everything in memory. So here we have a list of 3 integers. Here we have a list of 3 atoms, which are letters. And then here we assign this list to the letters variable. And then on this line here, we actually append the atom D to that letters variable, and it produces a new list with all the same items, but with D at the front of the list. So next we have strings, which there is no true string type in Erlang. So there is actually no true string type in Elixir. But that's all hidden from you. You can work with strings like you normally would, and most of the time you will never even have to think about that. So normally, when you create a string, you just simply use double quotes, and then inside the double quotes, you can put any UTF-8 characters you want.
Back on the slide where you're talking about the tuples, the bottom one right there. The one where you appended D to the beginning of the,
yes, the
right
list.
there.
Yeah.
That one you said now there's a new copy, and the original is called letters. When you add the D to it to create a new tuple, does that one have a default name, or does that just have?
No, I'm printing this here. Yeah, in actual like code, like in an actual program, you would probably take this expression here, and on the console, if you would execute this, it would just simply return that value, and it wouldn't be assigned to anything. Normally in an application, you would say like, new letters equals this expression, and then you would still have letters as the original list, but then you would have new letters as the list of 4 items.
Thank you.
So yeah, so letters is untouched, and the new letters, this expression produces a new list. So in strings are actually represented as binaries underneath, but Elixir hides this from you, so you can just put anything you want between double quotes as long as it's a UTF-8 character, and that's sort of a binary underneath, but you can treat it as a string just like you would in any other language. If you put a string in single quotes, it's actually represented as a character list, which is actually a list of character codes. So in the case of ABC, that would be 97, 98, 99. You can also get the character code for a certain character by simply putting the question mark in front of it. So this actually returns the character code for the letter A. You can put a character after the question mark and it will return the character code. So here we're actually constructing a binary with the character codes for A, B, and C. And then you can see it's producing a string that looks just like this string up here. Because strings are represented as binaries underneath, you can actually create binaries and then treat them like strings because of the same thing. And the same here, we have a list of character codes, which can actually be represented as a character list type. So it prints it out as a character list. So it looks like a normal character list. There's a few more data types. I won't really go into these, but they're just basically key value stores. They all have specific advantages and disadvantages. This one here is just a simple key value store. You can have multiple keys, each pointing to different values, and you can have however many keys you want. A struct contains a set amount of keys. So we actually don't use those a whole lot in Elixir, but they're used occasionally. Everything is stored in modules. Modules are how you organize your code. All functions, so like here we have a module called ping, and then we also have some module documentation. I imagine that's kind of like Java doc. I don't know, I haven't used it. But if you were adding functions to a module, you would just simply put the functions in here. And I'll go over this in a little bit more detail later on. And functions, this is 2 functions here. Functions in Elixir are identified by the name of the function and then also the arity of the function. So in this case, we actually have only 2 functions defined here. We have a function called add with an arity of 2. So that means there's a function named add that takes 2 arguments. And we also have a function called add3 that takes 3 arguments. Now, this is actually one function here. One thing that's unique about functions in Erlang and Elixir is that they actually have multiple clauses, they call them. So in this case, this function here, it's one function, but it actually has 2 clauses. So this is obviously you would never write this in real life, but to illustrate here, if you were to call add with 2 values, and each of those 2 values happen to equal 0, then this first clause would be executed. So over here in this do block, the body of the function would simply return 0. If the 2 values were not 0 each, then they would be bound to the variables x and y and then added and returned. So there's actually 2 clauses. This is one function with 2 different clauses. So based on what you pass in, the whatever matching clause, that function body will be executed. So it's kind of, you can kind of think of this as like a case statement of sorts, you know.
Yeah, it seems like operator overloading. Java?
Yeah, there's actually a little bit more going on, which I will get to in just a minute.
Okay.
This is actually pattern matching, which probably now this kind of looks a little bit confusing.
Feels
but
like Haskell.
I haven't ever played around with Haskell, but I imagine it probably is in some ways. So this is actually pattern matching here. So now I'm going to get into the basics of pattern matching. It'd actually be probably pretty hard to understand Elixir code or Erlang code without having a basic understanding of pattern matching. And it's used everywhere in Erlang and Elixir. And it's very powerful. And it takes a little bit of time to get used to it, but once you get used to it, I think you'll really like it because it's much simpler than the alternatives. So here we have, so first I should cover what the equal sign actually is. The equal sign in Erlang and Elixir is not assignment. It is actually a challenge for the VM to make two sides of this expression equal. So in this case here, we're comparing the two atoms, A. Well, in this case, they're both equal. But we're not assigning here. We're actually challenging the VM to make sure that this value is equal to this value, in which case they obviously are equal, so it simply returns that value. In this next statement here, we're actually challenging the VM to make the atom A equal to that, or the atom B equal to the atom A, which these are both literals, so there's nothing it can do to them. So it throws a match error and it blows up. So we know that these two aren't equal. And then here we have another expression, which is challenging the VM to make the atom A equivalent to the variable letter. Well, the variable letter is not bound to any value yet. So because it's not bound, and the VM is being challenged to make this expression true, it just simply takes that value and it binds it to that variable. So that's how variables are bound in Erlang and Elixir.
So what if you had flipped that? Is that legal syntax?
I think in this case, no. In this case, no, because letter would not be bound to anything. It would be undefined. So that expression would fail. I can actually, when I do my demos later on, I'll actually show you on the console what that would output. But yeah, that would fail. If in this context that was flipped, it would fail. But suppose now, after we printed out letter, which is bound to A, suppose we had another expression here where they were flipped, it would simply return the atom A because the literal on the left is equivalent to the value of the variable bound on the right.
So it does recognize L value, R value kind of ordering?
Yeah. So it definitely, if a variable is on the left, it will just bind that value to it. If the variable is on the right, it will complain about it being undefined.
So I don't get the part about challenge to make both sides equal. Because to me, and maybe, look, I'm 10 minutes in, so maybe you're getting to it, but...
Yeah, sorry, I didn't mean to interrupt.
No, I was just going to say, I mean, I get your point about L values, but it seems like if the challenge is to make them both equal, and one's assigned and one's an atom, shouldn't they just change the unassigned to the atom?
Yeah, I would think that would make sense, but it doesn't work that way. It only assigns values to variables on the left.
Oh.
If a variable is on the right, it's assumed to have a value.
Sounds a lot like the equals assignment. How is that really different from assignment?
Because if this had already had a value bound to it, say letter was up here bound to the atom B, and then we actually did this, it would actually complain with the same error here. And I'll go through some more examples. Hopefully that'll become a little more clear. But yes, unbound variables cannot exist on the right side of an expression. They have to exist on the left side. Once they're bound, you can use them on either side. But until then,
so it's a hybrid between a Boolean and an assignment.
Yeah, I guess so. Yeah.
Okay.
So this was just simple pattern matching between atoms here. So it gets a little more interesting when you introduce tuples and things like that. So here we have an expression where we have a tuple containing OK, which is maybe like a status code returned from some system, and then a string containing food, bar, and Baz. And then that is being challenged to match this pattern over here. Now this pattern has a tuple of 2 items as well, and it has a literal atom OK, and then this unbound variable foo. So it can make these 2 sides of the equation equal by simply taking this binary and binding it to this variable. Then both sides match, and everything's fine, and it continues. But now, we've actually extracted this value and bound it to the foo variable. So now wherever we have foo, we have that string there. So it's very convenient for extracting data from data structures. And there's much more complex examples that probably wouldn't occupy a whole lot more space than this example here, but they make it very easy to extract data from data structures. Here's another example. Suppose this other system, which is producing this value here, has something wrong with it. And so it actually returns a tuple of 2 items again, but this time instead of saying OK as the first item, it actually has the atom error. And then following that, it has the atom crashed. So something blew up. But over here, on the left side of our expression, things aren't even going to match because OK, the atom OK does not match the atom error. So there's no way this can match. So the VM throws a match error and says this value here isn't going to match this. So it blows up. Matching lists can also be done. So here we have a list literal of 3 integers. And then because adding things onto the beginning of a list and pulling things off the beginning of a list are very easy. Unlike at the end of a list, in this case, you would actually have to traverse 3 links to get to the last item. So that would actually be very expensive to do. And if you wanted to manipulate it, it would be even more difficult. So pattern matching makes it very easy to take the first item off of a list and then keep all the other items in that list in a separate variable. So here we have a list of 3 items, and using this pipe operator, it takes the first value in the list, binds it to the variable on the left of the pipe, and then takes the remaining items in the list and binds them to the variable on the right, which is tail in this case, and within these square brackets. And so after this expression is evaluated, no errors occur, and the variable head is now bound to the integer 1, which was the first item in the list, and then the tail was bound to the 2 remaining items in the list. So normally, this value here, the variable to the right of the pipe, is going to contain the remaining items. So it's either going to be an empty list if there's no other items in the list available, or it's going to be a list of values like it is here, 2 and 3. We can also, if we know we have a set amount of items in a list, we can just literally match them like this. So just like you would expect, commas between the variables in the pattern. So first is bound to 1, second is bound to 2, third is bound to 3. So all these variables are bound after this expression is evaluated, and there's no error here. If we thought we had a list with just 2 items, and then we tried to match it against a list with 3 items, it's going to fail. Because this pattern here says we're assuming the list only has 1 item. Do you guys have any questions about that?
Only one I have is, can you then put a comma after the pipe? So could you have first, second, rest, comma, last?
No.
I understand that would be expensive, as you said. But, yeah.
Well, actually, to be honest, I've never tried it, but I'm pretty sure it's not possible. These here, because this is in memory, this is that first link,
right.
This is that second link. So these are very cheap, and you could actually continue to chain these together. So in this case,
right.
We could actually do first, second, third, and then rest.
Yeah.
And so first, second, and third would be bound to the integers like we'd expect, but then rest would simply be an empty list because there's no other items in that chain of links there. And I didn't put that up here as an example, I don't think.
Now this works the same way that it does in Erlang?
Yes, this here is exactly the same. The only difference is in Erlang, the variables have uppercase, start with an uppercase letter.
Okay.
Wait, variables in Erlang have to start with an uppercase letter?
Yeah, so in Erlang, they start with uppercase letters, and in Elixir, they start with lowercase
Is
letters.
that to emphasize that variables are really all constants?
I'm not sure where it came from. I think, I don't know what the reason behind it
That
was.
would be a good rationale for it.
It came from the 80s.
Yeah, yeah, that probably was part of the reasoning, because atoms were just simply lowercase alphanumeric characters that didn't even start with a colon. Like here in Elixir, everything starts with a colon if it's an atom. In Erlang, this would be a valid atom. Second wouldn't be a variable, it'd just be an atom. So there's, and I think I've got a slide at the end of my presentation here that actually compares Elixir syntax and Erlang syntax side by side. I didn't put a whole lot of code samples together, but I think I have one.
The one thing I'll point out, the way that I understood how, like the very last example you got there, the way that I understood, if you imagine a list on the right has 20 items in it, 1, 2, 3, 4, 5, 6, 7, then what you get is first is 1, second is 2, and then rest is a new list consisting of 3, 4, 5, 6, 7, 8, whatever.
Right.
Because at the end of that function, you're just going to usually call the same function again, and now first is 3 and second is 4.
Right. So yeah, so this when we get into, and I'm actually going to get to that in just a minute, but when we get to recursion, this is very handy because a lot of times in recursion, you have a function that only works on one item at a time, and you want to go through a whole list and process all the items. So this is very handy because you can just be like, oh, take the next item on the beginning of the list and we'll process that, and then we'll just pass the next, or the remaining items to the next call of the recursive function. So some more examples. Variables, while like in this example here, the variable num is not bound to any value, it cannot be rebound during a match. So in this case, we have the tuple containing 2 integers, each of the same value. So over here, by creating this pattern with num appearing twice in the pattern, this will match, and num will be bound to 1 like you'd expect. But if this value on the right is 2 numbers of a different value, it will fail because the variable num is actually bound once, and then it tries to match this value against the value that's already been bound, which is the integer 1. So it fails because those 2 values aren't the same.
For the tuples to match, do they have to be the same number of elements on?
Yes.
Okay.
Yeah, so the thing you can keep in mind is that with a list, like, even if this list only had 2 items in it, this pattern here would still match, and this value would just be an empty list. If you're using the pipe in your pattern, you really don't have to make sure there's enough items in the list, as long as there's at least 2 in this case, or at least 1 in this case. But with tuples, it has to match exactly, because tuples are a set number of items, so it assumes, like, if you have a pattern with 2, you're looking for a tuple with strictly 2 items in it. And also, there's also the underscore variable, which is special. It's a variable as well, but it works a little bit differently than a normal variable like this. It's used in place of a variable, so in a pattern like this, we're doing a pattern match. Normally variables would go here and here, but in this case, we didn't care about the values that were being bound to these variables. So we use the underscore variable, and that works just like a normal variable. The only difference is the values that it's matching are never actually bound to the underscore. The underscore is kind of like this black hole. Anything you assign to it just disappears. So in this case, this tuple with 2 different items in it, which if you remember here, when we were matching against this, because it's being actually bound to the variable num, it fails. But in this case, it's going to succeed because it matches against the underscore. It matches, but it never gets bound. And then when it gets to this next item, it's not bound because it's the underscore, so it matches as well. So here you can see this one succeeds because it's using underscores. This one fails because it's using regular variables, which I would expect these 2 values to be the same.
So like in a pattern match, can you do underscore 0, so underscore then 0, 0 then underscore underscore?
So like creating variables that start with an underscore.
Yeah.
Yes, that is also valid. So normally what we would do, so suppose in this example here, like we didn't really care about the value being returned in this tuple, but we wanted to make sure it was successful.
Yep.
So
you just put it under.
we would just simply, but maybe we want to remember that like the value being returned is foo. So by prefixing foo with an underscore, that value is still bound to that variable just like it normally would, but because it's prefixed with an underscore, it reminds you that, hey, like that value is actually not being used.
Okay.
But in that case, the value is actually still being bound. So it's not like the single underscore where it's just kind of like it's never bound. You assign something to it and it just disappears.
Okay.
So it's a little bit different, but yes, that's very common when you don't care about a value. And then when you have a variable that's already bound to a value, like in this example here, you have Jose, and then you want to actually match on the left side the value of this variable against this value over here. Well, normally, if you didn't have the caret there, Joe would simply be assigned to username, and this would succeed. But in this case, we want to verify that this value over here is actually Jose and not Joe. So by prefixing it with a caret, it forces this variable to remain bound to this value and not be reassigned during this match here. So you can see in this case, because username is actually Jose, it's not going to match Joe, so it blows up, says there's a match error. But in this case, we actually have a tuple that has the name Jose in it, and it actually matches. Now this variable is already bound, so this expression here isn't giving us any new information, but it is verifying this data over here, or this value over here, is the same as what's currently bound to username. So something else you'll probably eventually use. It's not quite as common as the other cases. So this is when things get a little more tricky. So the arguments you see in functions, those are actually patterns as well. So these are not arguments, these are patterns that the arguments the parameters you're passing in are checked against. So in this case, we have this fib function here, which when, let's say we call it with a value of 0, it's going to start at the top of this file here, and it's going to work its way down until it finds a case that matches. So in the case of 0, it just matches, so it simply returns the integer 0. The same thing with 1. If it's passed an integer 1, it just matches this second clause here and it returns the integer 1. But if these two clauses fail, it falls all the way down to this third clause of the function, which is matching against the variable in. Well, functions don't inherit scope or anything, so in is unbound at this time. So it simply binds whatever value we pass to in, which in this case maybe it's 5 or whatever. And then this is actually a recursive function here, which I'm kind of jumping ahead by putting this in here, but basically, you pass in 5, and then you subtract 1 from 5, and you subtract 2 from 5, and then you compute the values of those values, and then you add them together. So I'll get to that in a little bit, but this is a recursive function where it's actually calling itself. And I have some examples that hopefully make that a little more clear later on. So I probably shouldn't have put that in there. But case statements can also use pattern matching. Case statements are very common in Elixir. I don't think I've ever actually used an if statement. Case statements are much easier and they're far more flexible than if statements.
So question, could you go back to the prior one? You just caught my attention, but never using if. So I realize this is just an example, but if this function was called with -5, I'm assuming you do something in the bottom one there that said case less than 0?
Yeah, so in that case, this would actually probably wind up in some sort of infinite loop.
Yeah, but I realize
this is actually broken. There's actually, if you pass in a negative number, it would result in some sort of infinite loop in the recursion, and it would just eventually blow up. So what you would normally do in this case, there's also called guards, which are basically additional clauses that you can apply to patterns. So you could say when in, and then you could have, or right between in here, you could say when in is greater than 1 or greater than 0. So if it's not greater than 1, this third clause is actually going to fail.
Oh, and
And then it would blow up,
Oh.
and whoever was calling this would say like, oh, you know, you must not, they'd figure out, well, you must not be able to call it with a negative function, or with a negative number. But yes, that's a bug here. I didn't really
No,
pay attention to that, but yeah, yes.
It was, I figured you were gonna get to it. I'm
Yeah.
not critiquing your code.
Yeah, no.
I just thought, if you don't
Yeah.
use this, how would you do it? But you just explained it.
Yeah, so a common pattern to use is to keep your really specific patterns as the first clause of the function, and then kind of have your kind of catch-all pattern at the very bottom. That way, you know, the specific clauses are caught first, and then you work your way down to the general one.
Yeah, does Elixir have those comprehensions?
It does. I don't actually use them a whole lot, but yes, they're built in and they're quite nice.
Yeah, they're quite nice for doing that.
What? Yeah. I actually kind of like there's some other built-in functions that kind of allow you to do the same thing, and it's a little more. It's not quite as elegant. It's a little more verbose, but I kind of like it better just for some things because I think it's a little bit easier to read. But the list comprehensions are nice for some things. So case statements also use pattern matching. So I haven't really shown you what a case statement is, but basically you have a case keyword and then you have an expression, which in this case is the do something function being passed some work to do. And then inside this body, between the do and the in tags, are all the cases. So the first case is that the value returned from this expression matches this pattern, which is OK result. So a tuple containing the atom OK, and then something that's bound to the variable result. In this case, if that matches, maybe we want to do something with the result. So we pass it off to this other function here. Or maybe when we call this do something function, it returns an error. So we receive this error tuple with invalid work or something. And so maybe we want to handle that. You know, we passed something that was invalid. We want to do something else. So that would be the second case. But then we usually want to have some sort of like wild card kind of catch-all case. So in this case, you know, maybe there's something that it didn't even return either of these two values, something we were not expecting at all. So we just bind it to the variable error, and then we just pass it off to this handle error function. So yeah, this is very nice because no matter what this function returns, one of these three actions will be taken. So that's kind of the basics of pattern matching. If anyone has any questions, I'm going to go into first-class functions and recursion now. And I don't know, well, a lot of time has gone by, so I don't know that I will be able to get through all of this. How long is this supposed to last normally? About an hour? So I think it looks like it's already been about 40 minutes.
Yeah, I mean, we're usually here, I think we have it to like 9, but I mean, we can go a little bit further.
Okay. Okay, so first-class functions. I imagine, like, it seems like most languages have first-class functions now, at least all the ones that I get to use. So you all are probably familiar with like how first-class functions work, and probably vaguely familiar with like passing functions around and stuff like that. So I'll try not to spend too much time on this, but there are some things that are unique to Elixir. So functional programming language, all functions are first class. There's two distinct classes of functions or types of functions. There are named functions, which are stored in a module, and they are identified by the module name, the function name, and the arity of the function. And then there's anonymous functions, which are just functions that are defined and assigned to a variable. They have no name. Anonymous functions inherit the scope of wherever they were defined. So the function that defines an anonymous function, that anonymous function will inherit the scope of the function that created it. Both types of functions can be referenced and passed around, so you can assign them to variables like we're doing here. So in this example, this is an example of a module called hello, which defines one function. It's one function with two clauses. And the function is named greet, and it takes one argument. So you can see here, there's two different clauses. So if somebody happens to have us pass in a certain value, we return a certain string. Otherwise, if it's some value we don't recognize, we just greet that name. So suppose we want to actually like pass this function to another function. You know, we could just call it here by simply calling hello, which is the module name, dot greet, which is the function name, and then pass in whoever we want to greet. So in this case, Jose, and it would actually return the string hello, Jose. I'm missing a quote there. I must have missed that when I pasted, but this is normally the way you would invoke a named function. It's just simply calling module name, function name, and you pass in the arguments, and it would execute. But maybe you want to actually pass this around. So you could actually provide module name, function name, and then the arity name after the slash, and then assign that, which is actually a reference to this function, to the variable hello. Then you can pass around hello, just like you would any other value in Elixir. And then whoever gets this hello value, when they actually say like, well, let's execute this and see what it gives us back, they simply they use that variable name followed by the dot, and then followed by the parens with whatever values they want to pass into that function, and then that function is executed. This syntax is kind of peculiar. They fixed most of the things that were really bad in Erlang have been fixed. As far as like the syntax goes, but this is one thing that's just like one of those quirks of the language. For some reason, like you actually have to put a dot after a variable that's bound to a function if you actually want to execute the function. So one little quirk there.
What was the ampersand you were referencing there? Hello, greet.
Oh, and hello.greet. This is just the notation for like this is just like the reference to the function. This is the way you'd represent it. So. I'm not exactly sure like why the slash was chosen to separate the function name from the arity of the function. Why it starts with an and.
And is traditionally in C the point.
Right. I think with which makes it kind of odd that they chose a dot here. I think with Elixir, they were pretty free to choose whatever syntax they wanted. So I haven't heard anything like specific about these two subcharacters here, so I'm sure they just thought that looked all right and they chose to go with it.
Why not, right?
But yes, this is a reference to the greet function that takes one argument in the hello module. Any other questions on that? And then anonymous functions, which these are the functions you kind of define on the fly, you know, within another function or within another part of the application. These anonymous functions inherit the scope of wherever they were defined. So in this case, like we create a closure here. So above this function, we're actually creating this, or we're binding hello everyone to the special greeting variable. And then when we define this greet function, we started off with the fn keyword, and then just like named functions, we can actually have multiple clauses. So this is the first clause on this line, and this is the second clause on this line. This is probably we should have chosen a simpler example for the first anonymous function. But basically, you invoke this function with one value. If that value matches sunjug, it returns the special greeting. Otherwise, it takes that value and concatenates it onto the end of the string and returns that string. So you see here we have actually created a closure, which I imagine you all are probably at least vaguely familiar with that. I don't know how that don't know if all this is available in Java or not, but I would imagine quite a few of these things are now. So then, once we've created this anonymous function, it's actually bound to the greet variable, just like any other value in Elixir. And then to invoke it, just like a reference to a named function, a variable that references an anonymous function, follow it with a dot, and then parens with the arguments that the function expects. If any of these, if you were to call them with the wrong number of arguments, you were to try to call them with 2 arguments, it would blow up because variables are referenced by name and arity. So here's a little more complex example. We actually have some user data here. So this is key value stores of user information. We put these pieces of user data in a list here. And then down here, we define a function that can take one of these users and fetch the first name key from that user's information. So from this this keyword list here, we can use this code here to pull out the user's first name, which in this case would be Joe or Jose. And then we assign this anonymous function, which allows us to do that to the first name variable. And then we can use the built-in enum map function and pass in all the users, which we've defined here, which is both of these users in a list together, along with the first name function. And then when we invoke map, map will just take this function here and apply it to every user in this list here. So then it just prints us out a nice little list of users' first names. So we have a list that contains Joe and Jose, just like we'd expect. So this is very nice because we can actually create this and pass this around like any other piece of data. And then when we say, hey, we want the user's first name, we just pass that in. Makes for very readable function calls. Here's a similar example, but this time, maybe like this example, we've hard-coded first name. Well, maybe we want to be able to define functions that get the value of any field defined in this data up here. So maybe we want to define a function that actually produces a function that actually searches for a field in user's data. So here, this is quite a bit more complex, but we're creating this get field function, which expects a field name, and then when you invoke it, it creates a function that searches it returns a function that searches for a user's searches through user data for that specific field. So here we are on this line here, we're actually using it. So again, we're passing in the list of users that we've defined up here. But this time, instead of passing in like we did before, our reference to the first name variable, we're actually going to invoke this getField function, which actually returns another function. And that function we return is actually going to fetch the last name. So in this case, we do the same thing as before, only we get the last name. But this time, it's more flexible because we don't have to go define variables for every field we want to fetch. We just simply define one function called getField, which produces those functions for us on the fly as we need them. So very handy, very common to use in Elixir. And it usually, once you get the hang of reading this, it's actually pretty simple and results in pretty clean code.
Is that keyword fetch function like a linear search through the list?
Sorry?
The keyword .fetch, is that like going item by item?
So the keyword, like this is actually called the keyword list here.
Oh, so that's more like a dictionary structure?
It's basically a dictionary structure.
Okay.
So yeah, this is just a module of functions that allow you to easily manipulate these type of dictionary structures.
Okay.
So fetch just says, you know, give me this field, and if this field doesn't exist because there's an exclamation mark, if it doesn't exist, blow up and throw an error or something like that. So yeah, this is basically just a function that makes it easy to retrieve a value from a dictionary. And these are all like the keyword module here and this enum module. These are all part of the standard library that comes in Elixir. So I will probably, I don't know, I've still got quite a bit to go through, but I guess I will try to, if anyone has any questions, yeah.
Take your time, keep going. I mean, if you
Okay.
ask anybody to leave, it's
Okay. Did you have a question?
Were you going to get to synchronization and concurrency features?
Yeah, I have that as the last thing I want to cover.
Skip
So
to that. Make sure you, you get that.
okay, so I'm probably going to be terrible at explaining recursion, so I'll just go over it as quickly as possible.
Could we go over concurrency first, or is that required?
Well,
If
recursion is kind of like essential for, like, you kind of have to have like a basic understanding of how
but I mean-
recursion works.
If you went through college, you understand recursion.
Okay, so I'll go through this like really quickly. So, recursive functions call themselves. There's no like sort of iteration. So if you need to do some sort of repetition, you use recursion. If recursive function always calls itself and never returns, an infinite loop is created. This is actually used in some cases. It's actually never infinite, but sometimes you create a function that's nearly infinite. That's very handy. So here, I'd imagine you all can probably figure this out pretty quickly, but we're pattern matching the first argument here as a list. We're taking the first item in the list and appending it or adding it to this accumulator value. It's the second argument. And then we're calling SumList again. So in this way, we're actually going to iterate through this list, and assuming it's a list of integers, we're actually going to sum all the integers in this list. So here's an example of what that looks like. These are called SumList with a list of 4 integers, and then an accumulator value of 0. And on each evaluation of this function, it's going to call itself with a different set of arguments. So in this case, takes the first item off the list, appends that to the accumulator, so 0 plus 1, and then it calls itself again, taking the 2 off of the beginning of this list and appending it to 1, and keeps on calling itself until it gets down to this very last case here, where actually the first argument is an empty list. And in this case, this function has 2 clauses, so when it gets to that empty list, it's only going to match the second clause. When it gets to the second clause, it's going to simply return the accumulator value. So it's just going to iterate, calling itself until the arguments that are being passed it match this pattern of the second clause. So you can see it's probably a little bit more confusing than like iteration in like Ruby or whatever.
But it's the same as recursion in almost any language, is it not?
Yes, yes. The recursion in Elixir, as far as I know, is there's nothing unique about Elixir or Erlang's way of doing it.
We know how recursion works at home.
Okay.
Okay.
So another example of recursion,
Gotcha.
there's how it would be computed, multiplying all the values until you get to just a whole bunch of values that need to be multiplied. They're multiplied, and then we compute the factorial for the value 5. Tail call optimization, this really isn't that relevant, so I'll skip over this. Basically, you've got 2 different versions of a recursive function. If the last expression is solely call to the function itself, it will be optimized, meaning no new stack level will be generated, and it will save a little bit on memory. Whichever method you choose in Elixir, you won't ever run out of stack levels until you run out of memory. So as long as the data you're working with is and the manipulation you're doing to it fits in memory, even if you're creating a new stack level for each item you're processing, you won't ever have a stack overflow until the memory allocation fails. So concurrency. Does anybody have any questions about that? I guess you all probably have a pretty good understanding of recursion, or at least good enough to go into concurrency. So recursion is kind of essential when you're thinking about concurrency, because basically every process, so every concurrently executing piece of code ends when a function returns. So I'll get to that in a little bit later, but before we go into that, it's probably good to have a little bit better understanding of the Erlang VM. The Erlang VM, or each instance of it, is called a node. You can have many nodes on one physical machine. You can spread nodes across multiple physical machines on a network, and you can configure them to communicate with each other. Nodes are nodes of the VM, and they're always one operating system process. Sometimes, like you can see here, a process has multiple threads. So in this case, we're on a 4-core machine. The VM says, can just create 4 threads. This is a very simplified example, but you can see it's creating threads in order to optimize the way the CPU is set up. In red, these are not operating system processes. These are Erlang processes. They are contained within the VM, and they are in no way related to the operating system processes running on your machine. That gives us some distinct advantages over like running, some sort of software where you're actually spawning up an operating system process for each thing you're doing.
So one VM, one process.
Yep.
It
One
operating
operating system
Gotcha.
process per VM. Yep.
So will it just like create a thread for every core that you have, or can you kind of limit that? Like say I have an 8-core machine, but I want a core like I know I'm going to use a whole core for something else.
Right. So the way it comes set up out of the box, it just like does whatever it feels is best.
Okay.
So I think on my machine, like it's whatever, dual core, quad core.
Yeah.
But I look at it and it's often running 17 threads.
Okay.
So for whatever reason, it feels 17 is the best number for my machine.
Okay.
It's all done logically and it's all computed by the VM.
Okay.
You can, there's config stuff that you could change, so you could reconfigure it to say like, always use 4 threads or always use...
Yeah, I'm sure there's like some use cases where that's
Yeah, yeah, so you can, all this stuff, like, it's actually, the VM is very configurable, but like, unless you're doing really, really high performance stuff, like, it's kind of not something you can manage. But, so yeah, so Erlang processes are not operating system processes. While you've got one operating system process that has multiple threads, but within the VM you have multiple Erlang processes, and each of those processes is doing something different at any given point in time. And so the VM handles all the logic of figuring out how to distribute that work across your physical cores and across the threads that it has. So you don't really have to worry about distributing work. Like, as long as you have enough Erlang processes running, the work will get done in a reasonable time. All processes are concurrent. All processes are equal. There is no main process. There's no main process, so there's nothing being branched off of anything else. When you start up the Erlang virtual machine, it always starts up one process. That process starts up other processes, but none of those processes are special in any way. They're just, one process has to be the first to start, and so that's what starts everything else.
It's got a different name.
Process?
Yes.
Yeah, I don't know why they chose to keep the same name, but I mean...
There it is, right. What?
Yeah.
So is all work?
And back in the 80s, they felt process was an appropriate name, so...
Is all work assigned to a process? I mean, if I just do hello world,
So yeah, so like if you were to pop open the console and like start typing away and just like create a little function that, computes the factorial of some number or whatever, that's actually executing a process, because when you fired up the console, it actually, on your VM, starts up a separate process for that console session. So if you could open 10 console sessions, and there would be 10 different processes running for each one. Now when you open up a console session, that one process is doing all the work and also handling all the interaction. So that within that one process, it's only doing one thing.
you said earlier that you just keep allocating stack into your own memory. Is there a limitation on the process?
Like how many processes you can create?
Or how much resources, can you assign resource limits to a process or control?
I'm not sure about that. Normally you don't ever even, like, I don't ever have to worry about that. I don't believe I don't believe it sets up any way for you to limit the resources used by a process. That's a good question. Most of the time, like, all your processes are doing like fairly equal amount of work. So it's not, you don't really have to worry about giving one process a higher priority over others. But yeah, I don't know if there's a way you can actually impose resource limits, but I don't believe there is.
As you mentioned earlier, we kind of implied that you were doing web development, maybe associating doing this with web development. So I mean, in case of something like a DOS attack or something, could you recover or,
Yeah, so Elixir and Erlang actually do very well in those sort of attacks because, like, whatever, you usually have, like, if you're handling, client connections, so you're handling, whatever, WebSocket connections. Well, normally, like, your code that's actually creating the connections and spawning processes for each user that connects, normally you're going to have some sort of limit imposed, just, like, maximum of 20 users, just because you don't want your server to get overloaded, or 2,000 users, or whatever your limit is. So, obviously, if you were another user trying to get on and 2,000 users were connected, it wouldn't work. But when you have multi-node setups on multiple machines, almost all those issues go away. So I'll get to some of that in just a minute. Processes are independent of each other. They cannot modify the state or the data that any of the other processes have. There is no shared data in processes. So if you give a process a piece of data, They actually make a copy of it, and then they work on their copy of it. So all communication is done via message passing. When you pass data to another process, it's actually making a copy of it.
Okay, so, question on that, apologize for that. Can you pass a message to a process that's running on a different VM?
Yes,
Okay.
and that is very cool because
Okay, yeah, that is.
you don't have to really. There is some. Normally, there is some like you have to actually configure some things, and
Okay.
like Erlang and Elixir, it's one of those things where it's like getting it to run, like getting a network of VMs to run on a Wi-Fi network is almost impossible. It's built for data centers where they're expected to have, every machine has Ethernet and probably has, static IP addresses and all that kind of stuff. So it's not the kind of thing that like I could show you on my laptop, but yeah, you can actually send data between servers just by message passing. And
I suppose you put 2 VMs on one machine.
yes, you can have as many VMs on one machine as you want. So a lot of times you'll have several Erlang applications running on one server, and you just create several instances of the VM. And because they're only one operating system process, even if you're running 4 or 5, it's usually not that big.
Does it have anything like a concurrent modification exception? In Java, so if you have a thread and someone else tries to access it and you've deleted some data out of it and they go looking for it and...
So
There's no shared data.
there's no shared data.
Can't do it.
So there's no way to do that with processes. Now when you're accessing things like obviously if you have 2 processes, accessing the same resource on the system, like maybe trying to access a socket at the same time or something like that. Like there would be cases where you're accessing external resources where you might run into issues like that. But as far as like when you're actually dealing with processes, none of that ever is an issue.
So it's just copies.
Yeah. And there is it is copies, but there is some stuff under the hood that is done to make it so that everything isn't always copied all of the time. There's some optimization. So like if you're passing around like massive 1 megabyte binaries between processes, you will actually just be passing around a reference, and then under the hood, if one of those processes wants to make a modification to the original binary, only then does it actually make a copy of it. So a lot of things under the hood that are done to optimize it, but you never even have to think about it. Just assume all data is copied, so the only time you need to be careful is when you're copying around tons of data. Processes are extremely processes are very lightweight. I'll show you in just a minute. I'll run an application that will actually spawn 10,000 processes and send some messages around, and it takes about, I think, 1.5 seconds for the whole thing to finish. While processes, they can't alter each other, they can be linked together. They can also be monitored. So you can say, maybe one process says, hey, if that process over there crashes or something, send me a message and notify me. Then the VM will, when it sees a process crash, notify another process. Or you could say like, 2 processes are chained together, so they're linked together. So if one crashes, the VM just take both processes down. So you could, maybe 10 processes are doing one piece of work. Well, if any process crashes, just kill all the processes in that group. That kind of thing can be done. So this is what message passing is like. It's just kind of, you fire the message to another process and forget about it. There's no...
But that's not a copy.
all right. But he no longer has access to it.
Right.
So processes are very much like actors in a sort of like object-oriented language. I'm not sure about Java, but I know Ruby had something called actors, and they were kind of experimental and nobody really used them, but they were kind of this idea that like you had objects that were like concurrent, and so they could do work at the same time, and then they could communicate by sending messages. And last I checked in Ruby, it was very primitive. But processes, when you actually get like a real world application built, and you have multiple processes running, and they're communicating to do work, they seem very much like actors, because each one's self-contained. All the data is contained within that process. Nobody else can touch it. So they're very much like actors, and they're almost like better objects in object-oriented languages because they're nicely encapsulated. They always provide like some sort of public API. And in addition to that, they're concurrent. So while one process is doing one thing, another process can be doing something else. And there's not like a single thread of execution like in normal languages like Ruby and stuff. So here's some code samples. To send a message, it's very simple. You just provide the process ID of the process that you want to send the message to, and then the message itself. So here, I don't know if you all are how familiar with Ruby, but you can omit the parentheses just like in Ruby. So we're calling the send function with the process ID and the message. And then to receive a message, it's a little bit more difficult because you actually, like, if you say you want to receive a message, well, maybe nobody sent you a message yet. So you actually block and you wait for a message to be received. So here we have a receive block, and again, pattern matching, just like the case statement. If we receive a tuple that says add and 2 values, maybe we add those 2 values. Or if we receive a tuple of 3 items with subtract and 2 values, maybe we subtract the second from the third value there. Or maybe, we get some random message that we don't understand. So it's an error. We won't handle it. So this is very common.
And underscore the unassigned thing was before, that's just a catch-all.
That's just a catch-all. So instead of using like we did before, we had the unbound variable error there. By using the underscore, we're matching anything, and we're not even binding it to a variable. So we really don't care about what's going on here because we're just throwing everything away.
So then what actually happens to the x plus y value or the x minus y value?
So in this case, I've made this, I kind of left the second part of this out. Normally what you would do, like if you're doing some sort of RPC system, you would actually take, like in the message you received, you would make sure that one of these values would be the ID of the sender. And then here on this line, when you add these 2 values together, you would actually do send, and then the process identifier followed by the expression you wanted to return. So in this case, x plus y.
Okay.
So this, if we added some extra logic here and added some send calls on all 3 of these lines, we could actually turn this into a really simple RPC type server thing.
Okay, so there's not some kind of magic return to caller going on with what's on the screen.
This is
all right, I just wanted to make sure I wasn't missing something.
Data is being received into this process, and then this process is
doing the calculation,
throwing it away. And then it's simply returning it to this local process. It's not sending anything back yet.
Could you receive 2 messages?
So with recursion, like this here, you will receive one message that matches one of these cases. And then normally you would have this encapsulated in a function, and you would just, when you got to the end of this receive block, you would just call that function again and wait for another message. So a lot of times, like if you were implementing some sort of server, you have this running, waiting for a message, and then you get a message and you process the message and maybe you send it back or maybe you store it or whatever you do. And then you just simply call this piece of code again and wait for another one. So that's how you would implement a server. This would be a very primitive server because it would only be able to handle one person at a time. But that would be how you would implement it.
And it would only process one message. So if 2 came in simultaneously,
Yeah.
it was on the third instruction, it would wait to take on the next message.
Yeah, so there's what's called underneath, you don't really ever really see it, but it's called a mailbox.
Oh.
So just like the actor model, all messages are asynchronous. So when, maybe your code is doing some work, and maybe while it's doing that work, it receives 10 messages.
Mm-hmm.
Well, it doesn't, it just finishes the work it's doing, and if at any point in time it wants to check the mailbox, it just simply does a receive call, and it grabs whatever messages are in there.
Okay.
But it's all asynchronous. So if you don't retrieve any messages, really receive is simply retrieving messages.
Oh, you give the next one out, and if there's nothing there, block.
Yeah. So
okay.
and there's no, as far as I know, there's no like priority for messages. So they just come in the order that they come in.
Can you limit the size of the mailbox?
Yes. If you're receiving messages faster than you can handle them, eventually that's going to cause a problem because there's just going to be too much stuff in memory. So yes, you can put limitations on the mailbox and stuff. I think that, I'm not sure, I don't have any examples of how to do that, but
That's a pretty powerful feature.
Yeah, you can definitely set limits because that would be important. You wouldn't want a mailbox to get too full. All right. So does anybody have any more questions about that? I think I'm going to show you some demos here, unless somebody else has something else they want to talk about here. So I had actually 3 demos, but I took one out just because I was running out of time.
Trevor?
Yeah.
How supervisor processes work?
So there's a lot of things that I'm not covering in this. There's a whole, basically like, the part of Erlang that makes it so powerful is a set of tools or set of libraries called OTP. It stands for Open Telecom Platform. And basically, it's a whole bunch of software that allows you to build concurrent applications without having to write like things that you commonly use, like servers. Like you don't want to have to write a receive block for every server you do because they're going to servers receive messages and they do things based on the messages they receive. So there's like all these common patterns. So with OTP, it's basically just a set of tools that allow you to define supervisors, and they call them gen servers. They're just generic servers. There's generic state machines. There's all kinds of other things. And it basically gives you all these building blocks. And so with like a supervisor, like it's all this logic that allows you to create a process that supervises other processes. And then you say like, hey, the supervisor process, I need another, whatever. In this case, maybe I need another ping process. So create me another ping process. So the supervisor goes and it creates another process, and it monitors that process. So if it crashes, you have a policy set up. So maybe if it crashes once, you just restart it. But maybe if it crashes 5 times in a second, maybe you say, hey, there's something wrong here. Like, we shouldn't restart this. We should do something else. So you can set all kinds of restart policies and ways to monitor processes and stuff. So the whole system, usually when you're designing an application in Erlang and Elixir, you have this whole hierarchy of supervisors. So you can have supervisors supervising supervisors, and at the very top level you have your one process, which is the actual running application of the system. And if that crashes, then the VM goes down and you have real problems. But at each level you have all these supervisors. So maybe you have a WebSocket interface on your web application, and maybe you have anywhere from 5 to 1,000 users using these WebSockets connections. So you create a WebSocket supervisor, and then whenever a user comes in and says, hey, I want to use the WebSocket interface, it just goes, okay, supervisor, create me another WebSocket process. And it goes, boop, returns you the process, the ID of that process, and it monitors it for you. So then, that user is able to interact with their own WebSocket process, and it does the WebSocket logic for them, whatever the client wants. And then if it crashes or it breaks or something, maybe the user, while using the WebSocket connection, finds a bug, the supervisor will restart it. So it's very powerful. That's really what OTP, the software there, is really what allows us to build these fault-tolerant systems that have the great reliability and stuff. Because even with the stuff that Erlang gives us, concurrent programming can still be very difficult.
Is OTP, would it be like mixing? Would you use it in a mixed case where you're mixing Erlang with Elixir? Or can you use it straight with Elixir like you can use it straight with Erlang? Or is it not ported yet?
Yeah, so
or how does that work?
So yeah, that was something I think I kind of skipped over very quickly. But another strength of Elixir is that because at runtime everything's the same bytecode and it's all running on the same VM, you can call any Erlang module from Elixir, and you can call any Elixir module from Erlang. So there was actually like a lot of the stuff you see in Elixir, like there is almost no porting of the code done. They're just using the Erlang code right there. In some cases they did kind of port things, but a lot of times you look at what they ported and they actually just like change the case of the module names and stuff just to make it fit with the Elixir conventions. But yeah, that's another great strength is if you find any Erlang module and you don't want to have to write Erlang code, you can simply add that Erlang software as a dependency of your Elixir app and just start using it like you would any other Elixir code. So This is one example I'll show you. This is really basic. Basically, I'll start up the shell, and then I'll create two processes, one called ping, one called pong. And then I will tell pong that ping sent it a message, and then it will respond with a pong to ping. And then ping will send a ping back to pong. This is absolutely pointless, but it creates an infinite loop, and at each time it passes a message back and forth, it prints something out to the console. And you'll actually see, as you were mentioning, when two things are using a resource. So in this case, we're going to be using standard out to print stuff. Well, there's two processes running concurrently, so there's no guarantees who is going to get print. There's no guarantees on the order that that data is going to be printed out. So while we know we're going ping pong, on standard out, you're going to look and you're actually going to see there's cases where it's not ping pong ping. There will actually be two pings in a row and then two pongs in a row in some cases. So I'll go out here and all right. So this is my ping application. I'll just open it up real quick. So I have a ping pong module, which has a start function in it, and it uses this function called spawn link, which is actually how you start a process from another process. A spawn link actually spawns another process, and it actually links it to that process. So if either of those two processes crash, both are killed. So we create one process for ping and one process for pong, and we start the loop function in both of those, and we pass them no arguments here. Ping and pong are actually the same, and I probably could have used the same function for both. But so in ping, we wait for a pong, and this pong message actually contains a process identifier or a PID. So then we can take that PID and send that PID a message with the ping message back. So when ping receives a message, it sends a ping back, along with a reference to itself. Self is another one of those kind of like magic variables. It always references the current process. So if you want to send somebody else a reference to that process you're currently working in, you just type self, and that's a reference to the current process. And then when we receive a ping or a pong, we simply print it out. So there's an IO module, and we use puts, kind of inspired by Ruby, but it's a little different.
Does the order of those two lines matter? Like, could you do the I/O before the send?
Well, you could. I mean, I guess you're printing to I/O, so like.
Yeah, I don't think that would make a difference.
It's. I mean, assuming the send succeeds all the time, it wouldn't really make a difference. But in this case, like, imagine something went wrong with the send function call, and everything crashed. In this case, this isn't going to be printed because it crashed before it got there. I mean, this is probably the more logical way of organizing it because you don't print until you're sure that you've actually sent a response. But yeah, you could actually flip these around and it would still run. And the only time something would work differently is if there was actually an error on one of the lines.
And it's interpreted, did you say?
So it's compiled down to bytecode. It's kind of,
so you can catch a syntax error.
so all the Elixir syntactic sugar and stuff, that's all done at compile time. So the bytecode is the same as what you'd be dealing with Erlang. There's just some stuff at compile time that's different. So I will fire up an IEX console here, which is alright, so now I've got the console open with the application loaded in it, so I can type ping pong here. And there you can see we have a ping pong module, and I can actually type module info, and that actually just prints some information about the module. So you can see we have a start function here, which was the one I showed you. So I can actually just type start. When I do this, it's going to execute that code that starts both of those functions, and then after it starts both of those processes, I should say, and then it's going to send a message to the first one, and then they're going to go back and forth. I just realized I forgot to show you guys something. So in the ping and the pong process, we only have this loop function, and if this, because we're spawning this process by invoking the loop function. So as soon as this function returns, that process is assumed to have been done, and it just simply exits without an error. So in the case of ping, we want to have it running and always receiving messages and then responding whenever it does receive one. So we want it to just sit there constantly and wait for pong messages to come in. So in this function, we immediately go into a receive block, and we wait for a message that matches this pattern here. And once we receive a message that matches the pattern, it does some work. And then you can see here at the end, we're actually calling loop again. So it's a tail call. It's a recursive function. It just calls itself over and over again. It will never actually return unless something crashes or something. It just always is listening for a message. And so that's how you create a process that runs a long time. It's just simply setting up a recursive function. So now we'll run it. Ping pong start. And it's going to go crazy and just print tons of ping and pong messages to standard out. And so there it goes. And I can actually kill it if I want. But one thing to note, I'll restart it in just a second. One thing to note, I don't know, sometimes you can actually see here.
Yeah, not yet.
Yeah, it looks like they're all in order at the moment, but occasionally you will see a message that's out of order. Looks like today they're all pretty much in order. But because this code that's actually printing to standard out is in a different process, my console is still actually usable. Now because it's printing to standard out, it messes with things, but you can actually see I can actually type stuff in here. Now if I could hit enter fast enough, I could actually execute it. Normally you don't ever print stuff to standard out that quick. So that's kind of like the really primitive demo of two processes sending messages back and forth. Yep.
I noticed when you had to open the shell, it said height. I'm assuming that means that the height compilation was enabled. Would that be true? And do you benefit from that in Elixir? Because I know height compilation is like experimental or like the right?
Yeah, I believe so. Yeah, I think that you talk. Yeah, right here. Yes, this actually. Yeah, because underneath it's still Erlang. You'll see stuff that's actually from Erlang. So this line here is actually the same line that you would get if you were running an Erlang console. So yeah, it's the same thing as what you would see in Erlang. So yeah, I'm assuming that means Heap is enabled and stuff.
Do you find any weird crack? Because I mean, I know like I've seen before, Height is an experimental type flag that you can enable in Erlang itself. Some people report various random crashes and stuff like that. Do you experience anything?
I haven't. I haven't really looked into it. I think I'm pretty much running this with the default settings that the VM was configured with when I built it. This is Erlang 17. I don't know. I don't think it's actually. I want to say that on Erlang 16 I'm not using height. So maybe, John, do you know anything about that?
I've never seen height in there.
Okay. I want to say that on Erlang 16 it's not used. I want to say I want to say there's some flag in the process that I used to build Erlang 16 that says actually no height. Right. But I'm not totally sure on that.
Okay, cool.
But yeah, I would imagine if it's there that it means it actually is using it. So this is a message passing diagram showing how the shell process, spawned two processes called ping and pong, and then these blocks here indicate the process was waiting for a message to come in. So we sent ping to this waiting pong process, which then sent it off to ping, which then returned it to pong, which continued to do that until I killed it. But this is just a little example of how the messages were being passed around. And each of these are processes, so everything's happening concurrently. So while this is happening, had I been able to type in the shell, I actually could have done more work and called other functions at that same time.
Can these supervisors that you spoke of, can be assertions be applied with that, or is it just something there to manage the bounds of the
Assertions. By assertions, you mean like?
Yeah, like so the process blows up or does something improper and comes back. Can the supervisor do something with that, or is it just a cleanup mechanism?
It's normally used as a cleanup mechanism. There are conditions you set, like if something crashes and the supervisor is set to restart it. I know you can set policies in place that things are only restarted under certain circumstances, and a certain set of.
Trying to tie that into my earlier question about artificial intelligence. So you're trying to draw some inference from something that you go down some kind of decision tree. You don't reach a conclusion that you can learn from to make a new inference with. So you kind of pair it off. You want to go try another one.
Right. So
procedural programming is very bad at that, right? So you want something maybe you can come back and say, hey, that didn't work, go this way.
Right. That's the kind of thing. A lot of times, like I try to avoid putting any sort of like business logic or any sort of application-specific logic in the supervisors, because supervisors are built with one goal in mind, and that's simply to monitor things and restart them when they fail. So a lot of times, but there's nothing stopping you from creating another process that keeps tabs on those other processes that are doing the computation, and then maybe those processes, when they get to a certain depth in this analysis, they say, hey, we've gotten this far, we're giving up. And so maybe they send a message to that other monitoring process that then is logging all this computation. And yeah, so if a process does get somewhere and it decides, I don't need to do anything else, it could send a message to another process and then just exit normally. If you can set it up so if a process exits normally, the supervisor will say, hey, well, he must have been done with his work because he exited, he didn't crash. So it is quite flexible, but normally you try to keep the application logic outside of the supervisors. So this is a little bit more interesting demo than the ping pong demo. I'm going to set up a chain of processes. I'll start out with maybe like 1,000 processes, and then I will set them up in a chain. So each process will have a reference to the next process in the chain. So I'll construct the chain backwards. So if this was like a clock, I'd be starting at 12 o'clock and working back till 1 o'clock. And so I construct this chain, and then once I created the last process in this process chain, I'll create a controller process, which ties those two ends together. And then I can send this controller process messages. And I can say like, hey, send this message around the chain 10 times. And it will send that process around the chain until it sees that process go around 10 times, and then it will return. I've also put together some timing logic in here, so it'll actually print out the time it took to actually send the message around. The times are very quick, but because it's simply passing data around, it's not actually manipulating the data in any way, it's a whole lot more performant than it would be in a normal real-world situation, because normally in the real world, you're actually, when you pass data to another process, you're either expecting it to store that data or send that data to another system or do some sort of computation. So I was trying to put together some sort of message passing diagram because these are actually a chain of processes. I wasn't able to represent this very well, so I also put together this diagram here. So we sit kind of at the top here, and we spawn this controller process, which then creates, in reverse order, creates each of these chain processes, which contains the reference to the next process in the chain. Once that's done, we can here say, hey, send this message around, and it sends that message around the chain as many times as we tell it to. So for this,
you use Vim for everything?
Yeah, I do. Vim and tmux for everything. I
can understand tmux, but not Vim.
I'm the other way around. I wish I could get rid of team-ups and just just never have to leave them. But
I feel old.
Okay, so in this main process chain module, this is where all like the processes that we as the user will call. So these are the two most important functions here. Both of these functions take 3 arguments: the number of processes that we want to spawn, the number of times we want to send that message around that process loop, and then the actual message that we want to send around that loop. So the message has to be some Erlang data type. And then this start timed actually will start a timer when the message is sent, and then it will stop that timer once the message is received. So we can time the total time it takes for that process to make it around that loop. And also contained within the timing is the time it takes to set up the processes in that chain, send the message around, and then also tear them down. So the time is the time it takes to set up and tear down everything, as well as the actual sending of the message. So in the process controller, in the chain controller, we have a start function, which sets up the timer and then waits for the start message to be received, which contains the link to the first process in the chain. And then for each of the chain link processes, each of them receives the process ID or the PID of the next process in the chain, and it passes that around along to each call to itself, each recursion to this receive block. And when it receives a shutdown message, it will simply end, and when it receives a message that it doesn't understand, it's assumed to be a message that's going around the chain, so it sends it off to the next message in